exponential function, and the base is 2. So we had a formula in chapter 5 that it is in 5. It's in 5.5 example 4.
And this is on top of the theorem we have to memorize, right? Or is this part of the theorem?
Well, this isn't going to be on the quiz, but if this shows up on the final and you don't know the formula, then your SLO is something else. Okay, so if I look at question 8, you do not have to have it memorized for the quiz per se, but this is something that if this would show up on the final without knowing the formula, it would be rough to get it. So here's the formula. The base, so the integral of a to the x dx is equal to 1 over ln of a to the x plus c. So let's jot that down here. So this would be definitely something I would add to your list of things to look over. If you do not, I do not expect that you have that memorized per se, but this is something I would definitely add to your list. Because without it, it would be rough to get the right answer.
Don't we need to know the derivative of a dx too?
Yes, I would also know that. Yes, I think we did that a couple on another review on. But so this would be, if you know the formula, it's pretty straightforward. So this is 1 over ln of 2 times 2 to the x, and this actually isn't plus c because it's it's definite. So we'll evaluate it from 0 to 2. So I can factor out 1 over ln of 2 if you want to. I'm just going to go ahead and leave it in. So 1 over ln of 2, actually I'll just leave it out. 2 to the second minus 2 to the 0. So 1 over ln of 2 times 4.
No, 3.
4 minus 1, yeah. 2 to the 0 is 1, so 4 minus 0 is 3. So 3 over ln of 2, which is D. Double check. It should be D.
I know how to do all this stuff. But
Again, correct. So I would put this on a list of things that you need to know pretty well for the final. Huh? Oh, okay. I thought you were talking to me. I'm like, no, that's not my job. Okay, D is correct, yes.
What's this formula called?
It's in 5.5 example 4. So it's the integral of bases other than e. So there's where it's at. And the derivative one is in 5.5 as well. Before example 4. Okay, 9. Suppose f is a continuous function such that the integral from 0 to 4 of f of x dx is 12. What is the integral from 0 to 2 of x f of x squared dx? I'm thinking. We'll come back to that one. I'm not going to waste time trying to think about it right now. I don't know. Okay. Okay, 10, we've seen one like this before. F double prime of x is 1 over x squared. F prime of 1 is 0. F of 1 is 5. What is f of e? So we're going to have to work backwards. I give you f double prime. So I'm going to rewrite that as x to the negative second. We're going to integrate or take the antiderivative to get to f prime. So that will make it x to the negative first. What goes in front? Negative plus c. So that is negative 1 over x plus c. And I rewrite it. And then they're going to give you information to find c. So how do I find c? Yeah, so when I plug in 1 for x, I get 0. So negative 1 over 1 plus c. Add 1. So 1 equals c. We've done one like this before. So f prime of x is negative 1 over x plus 1. If I go to f, what's the derivative or the integral of 1 over x? Yes, so that's negative ln absolute value of x plus c.
Why is it plus x?
Because the derivative of 1 is x. Or, I'm sorry, the integral of 1 is x. Working backwards. Let's evaluate it. When x is 1, I get 5. So,
Is that negative ln?
yes, because it was negative 1 over x. Oh, I didn't plug in 1. 1 plus 1 plus c. That's kind of working out weird. Negative ln absolute value of 1 plus 1. What's ln absolute value of 1? What's ln of 1? Yeah, think of a ln graph. Here's an ln graph. And it always goes through 1, 0. So when x is 1, y is 0. So that will become 0. So subtract 1. So 4 is c. That one's kind of weird. You needing to know that ln of 1 is 0. And then, so that gives you f of x equals negative ln of absolute value of x plus 4. And then you need to evaluate this at e. So plug in e. So negative ln absolute value of e plus 4. Yep, ln and e cancels, so that's negative 1 plus e plus 4, which is e plus 3. Seems something like it, ln kind of made it trickier, but questions? Okay. Average value, we haven't touched on it yet. It's not bad. You need to know the formula. Is it on your theorem? Is that a theorem one?
Average value theorem?
Is it on there?
No.
No, okay. Average value, I believe, is in chapter 3. Let me check. No, there's a specific. Let me look at chapter 3. Actually,
Do you have a bunch of whiteout? I could wipe this entire thing out.
That would look so good.
no, it's fine. I'll just say something to them and they will. Actually, I'll think of what I want to do. Because saying something to them will have no effect, so
Punish.
You're gonna mull it over.
it won't have no effect. We'll see.
Punishing them.
Okay, it is on section 4.4,
They're animals.
example 4. So 4.4, example 4. The average value formula is this. Another thing you're going to want to know, otherwise doing this would be hard. Again, not bad once you know the formula. We've seen it before. It's been a while though. Okay, so b is 2, a is 1. So 1 over 2 minus 1 times the integral from 1 to 2 of 1 over x dx. So I plug in a, I plug in b. So this becomes 1 out front. The integral from 1 to 2 of 1 over x. I don't know, that was kind of stupid to simplify that. But the integral of 1 over x, ln of x, ln absolute value of x, from 1 to 2. And then ln of absolute value of 2 minus ln absolute value of 1. Again, ln of 1 is 0. So ln absolute value of 2 minus 0. So I believe it is D. So again, not bad, but if you did not know that formula, you wouldn't be able to get it. You could maybe take a guess, but yes.
So why did you change 1 over x to ln of x? Like I know they're
Because that's a rule.
like they're
The integral of 1 over x is ln of x.
just the same thing, right?
The integral of 1 over x is ln of x.
Okay.
Yeah.
But why did we do that?
Because that's a rule.
It's just like okay.
Like the integral of sine is cosine. Just one of those things. Okay. 12. Mean value theorem. So it has shown up a lot. It's on your going to be on the theorem quiz. What section did I say it was in? 3.2. So section 3.2 again. The mean value theorem in differential calculus relates average and instantaneous rates of change for certain functions on certain intervals. To which of the following functions and intervals does the theorem apply? So let me look at the theorem. 3.2. I'm assuming it is an issue with being continuous or something like that, but let me get it out. I'm assuming that's what they're looking for, but let me. And I think we had one on the test where it wasn't.
Isn't it the open interval?
Let me look.
I thought it was.
Okay. 3.2. Let me find that theorem. Rolle's theorem and mean value theorem. Okay. Mean value theorem. If f is continuous on a closed interval AB and differentiable on the open interval AB. So let's check continuity first. So if I check continuity, where is, if I look at 1, which of the following does not, to which of the following functions in interval does the theorem apply? Okay. Continuous on the closed interval. So where is functions does the theorem apply? F is continuous on the closed interval.
It can't be true for sure. It's not even asking.
So, f is continuous on the closed interval, AB. So, okay, so let's check continuity first. Sorry, I'm drawing a blank, but we're good. Let's check continuity. Where is this not continuous at? I cannot take the square root of what? Negative. So any value, if I think domain here, any value bigger than 1 will get me a square root of a negative. So will I get square root of a negative between 0 and 1? No. I can plug in 0 and get 1. I can plug in 1 and get 0, so we're good so far with continuity. Second one, same sort of idea. We're good between 0 and 1. And 3, my continuous, this is 4x minus 1. This is absolute value. And there's really not any restrictions on absolute value. You can take the absolute value positive or negative, so we're good with that. Next one, is it differentiable on the open interval AB? Then there exists a number C in AB such that f prime of C equals f of B minus f of A over B minus A. Let's try that and see where that gets me.
Isn't number 3 not differentiable?
Okay, so yeah, so
It's differentiable.
differentiable is you can take the derivative. So I cannot take the derivative of an absolute value.
Why not?
You just can't.
Magic.
You can look at the graph. So if I graph this, I'm assuming I have, let's see if I think about graphing this.
Sharp turn.
Yes, I'm assuming I have, how do I want to graph this? Think in my head. So I would take X and I would go 4 and right. So you're going to have a sharp turn at 1. So this is not differentiable at 1. So this is out because it's not differentiable on the closed interval.
Explain that process again.
So if I think about graphing this, absolute value of X is like this. That parent function is like this.
Right.
Multiplying by 4 is just going to like stretch it, and then subtracting 1 is going to move it right 1.
Okay.
And it cannot differentiate. It's not differentiable. Even though it's continuous here, it's not differentiable at a sharp turn. So it's not differentiable at 1. So that's why it can't be 3.
And then what about 2? Because 2 is on an open interval. If it gives an open interval.
Yeah, but it's.
Shouldn't it give a closed interval?
I don't know if that would be that. Let me think.
Or is that not how that? Because I don't understand why that one's on. It gives
Yeah,
an open interval
apply.
instead of closed interval.
Is it differentiable on the open interval? If I take the if I think about the graph of this,
It should be differentiable on the open interval.
let's think about graphs. So if I take the graph of this, it's x squared, which is it's square root. We can just plug in points. 0 is 1. 1 is 0. And so something like that. That would be differentiable.
Right. But is it like, I mean, I don't understand why it gives a closed, it gives an open interval instead of a closed interval like the other two.
Right, but I don't know why that would make a difference. I'll check on that one again. At least we got 3 out. The answer is A only. It's 1 only.
One only. That's
But I don't know how we can cancel out 2 and not 1. I'll check on that again.
right, because they're the same, but like.
Yeah, I'll see what Yoder thinks. It does, but it also it has to be continuous on the closed
First, right?
and differentiable on the open.
So would you just like?
So I don't know why you could.
Right, because then you could just say that was the
Yeah, I don't.
closed interval.
Yeah. Yeah, I'll check on that one. I wouldn't stress too much about it, but we'll check on that. Okay, that's multiple choice one.
That's what
I split that one up into 2. Okay, short answer. Section of it.
Yeah. Keller.
Yeah.
Got stuff for you.
Huh?
That was very violent. Could be down as
Tapers on it? I want to make up a nice happy and. Oh, that's what it is.
Dylan, did I give you a card? No, it's on my desk.
A what?
From Ava. I'll grab it.
You just hand me something?
No. We do not.
I'm gonna use your derivative.
4.
No, big job application.
Where I was derivative.
Big job application.
Oh, big job.
I see you said a big job.
So you use McElroy, the guy you housed it for, and you're in a real job.
Hey, 13. So you're not going to use me for your fake job?
And McElroy, you can't
No,
use
I'm
3
not using
teachers.
this one. No, Miss Wheeler.
Okay.
Keller, and I didn't this one.
Okay, 13. These should look familiar. Following questions pertain to the function f of x equals x squared minus 4x plus 6 over x squared. The derivative and second derivative are f prime of x is 4x minus 12 over x cubed. F double prime is 36 minus 8x over x to the fourth. We're going to go through, we've done some like this before. From all the ones I've seen, they give you the first and second derivative. So hopefully that is what you'll see on the final, but we'll see. Domain. Domain, we look at the original. Yep. So you can have 0, everything besides 0, because 0 will get you 0 in the denominator. So negative infinity to 0, 0 to infinity. And they use this symbol, which means it's the union, so you take both of those. I would maybe throw that in just because that's what they have, just so I don't have to take off a point for not putting that.
Do I really need to put that?
I would, if this key says to put it, I would put that.
Well, how are we supposed to know what the key says?
Well, this is the key for this final. So if this is the key for 2014, then I would probably just put
Would
it.
you take off points?
I wouldn't, but I don't have a say.
No, for
But-
putting it in.
yeah.
Could you take off points if we?
I would say no. So I would lean on the side of putting it in, and yes.
Put more than enough stuff.
On what intervals is f increasing?
I think you just took the top.
Yeah, yes. Yeah, so as I look at the intervals that f is increasing, decreasing, we need to find the critical points first and then split up the domain. So we're going to look at the first derivative equal to 0. When I have a rational function equal to 0, I'm only worrying about the top part. Oh, I'm doing this the hard way. So 4x minus 12. 12 equals 4x. 3 is x. So 3 is one critical point. Your other critical point is technically what? 0, because that's where the first derivative is undefined. Don't forget to check that. So the critical point is where the first derivative is equal to 0 and where it's undefined at. So when I'm looking for intervals of increasing, decreasing, we're going to take, that 0 is already taken care of in the domain, so negative infinity to 0, 0 to 3, 3 to infinity. It doesn't specifically ask for a point, so you do not need to know the y value that goes with x with 3.
Just as a refresher, though.
If you need to know y, if it asks a graph, it doesn't ask a graph. If it would ask for graph, you could just plug 3 into the original and find what that actual point is. And 0. 0 is a vertical asymptote, I think, though. So we're going to check the intervals by plugging into the first derivative. So negative infinity is 0. Let's plug in negative 1. So that gives me negative over negative, so positive, increasing. 0 to 3, let's plug in 1. So 1 gives me negative, decreasing, into the first derivative. 3 to infinity, 4 gives me positive, increasing. So it's increasing from negative infinity to 0, union 3 to infinity. Because I'm counting both of those. Concavity, I look at what? Second derivative set equal to 0. So this is what I'm saying. Even though you freak out a little bit because you can't use calculators, but because of that, things are going to work out pretty nicely, like ones like this. So if I set equal to 0, 0 equals 36 minus 8x. Negative 36 equals negative 8x. Divide by negative 8. I just said how nicely it worked out.
Yeah.
Which is 4 halves.
9 seconds.
What is it? 4.5?
4.5.
4.5. Yeah, whatever. It doesn't matter either way. 9 over 2 or 4.5. So that's an inflection point. I also have an inflection point at 0. So technically these are both inflection points if they would ask for inflection points on the final. So I split up my interval using the domain. So negative infinity to 0, 0 to 4.5, 4.5 to infinity. And we plug into the second derivative to check concavity. So negative 1 will give me positive, concave up. If I plug in 1, that will give me back positive, concave up. If I plug in 5, that will give me negative, concave down.
So, do I always need Q if there's like two intervals?
Do what? Yes, I would say just yes.
Slap the Q.
So negative infinity to 0, union 0 to 4.5. Do not morph them into 1. You cannot be 0. So you couldn't put negative infinity to 4.5 because you have to have the split at 0. Okay, D, list any local extrema and identify the top. Justify your answer. So extrema, we already did the work part of it. Extrema comes from the what?
The first derivative.
First derivative, critical points, 3 and 1. We are looking at, so I know my critical points are x equals 3 and x equals 0. How can I tell whether it is max or min?
Decreasing.
That's what I would do because it's already done for you. So I would maybe just jot that down again.
Yeah, I'm checking points.
And say x equals 3 is a what? Max or min?
Minimum.
Min, because decreasing to increasing. But you know, I would just kind of read out. X equals 0.
That doesn't get anything, right? It's
Right, because 0 is going to be a asymptote, so they don't even have that listed. Now, you could also justify it, so that'd be one way. You could also justify it by the second derivative test. If I have the second derivative, or, I'll show you both options, or you could justify it by the second derivative. So the second derivative is, so if I plug 3 into the second derivative, that will get me back 12 over 3 to the 4th. I don't know. 90 something. 91? Are you just gonna say? It doesn't really matter. It's greater than 0. So since the first derivative or the second derivative, when I plug it in, is a positive, it is minimum. So either way would work.
81, not 62. 81. Wait, so you take your value from the first derivative, plug it into the second derivative?
Yep, second derivative test. So you take your critical point, plug it into the second derivative test. If it's positive, it's a min. If it's a negative, it's a max. So either justification would be fine. Okay, vertical, horizontal asymptotes. Vertical. Vertical asymptote.
Vertical, the things that are this way.
Yes.
Um,
How do I find vertical asymptote?
I don't remember which one's which.
Bottom equal to 0.
Okay.
So take your denominator equal to 0, so x is 0. Horizontal asymptote. Remember how to find that?
Where's that defined?
There's a shortcut,
I don't know.
but I would lean on the side of showing more work than just assuming that if you put your answer. So since it's a polynomial, we can look at the degree of the top and bottom. The degree of the top is 2, the degree of the bottom is 2. They are the same, so look at your leading coefficients, which are both 1 over 1. So your horizontal asymptote is y equals 1. I would maybe go ahead and, well, that's all they have, so I would.
Right.
That's important. This is all they have is y equals 1. So if you remember that shortcut, great. If you don't, it is the limit as x approaches infinity. So this is how you would do it if you don't remember that shortcut. Over a polynomial, I can go ahead
and divide everything by the highest degree on the bottom. So x squared over x squared minus 4x over x squared plus 6 over x squared, x squared over x squared. So 1 minus 4 over x plus 6 over x squared over 1. And then if you have a constant over x to any power, those are 0. So 0, 0. So that would also get you a 1. Technically on the key they don't have any other. They just have y equals 1. So, but in case you forget that shortcut, this is how you would do it. Okay. Next one should look familiar. How to get started. 14. Area enclosed by the curve x squared minus 15 and 12 minus 2x squared. Please simplify your answer. First up.
12 minus 2x squared.
Yeah, but we're going to graph it, and we know this is going to be what type of problem?
Integration.
Integration. Anytime you're looking for area, under curve, between curves, whatever, it's going to be integration of some sort. Let's go ahead and sketch the graph, see which one's above and below. Technically, you probably don't need to sketch the graph to see which one's above, below, but we can. Right, so you know that x squared minus 15 is going to be going up, and you know 12 minus 2x is going to be going down. So we're assuming this one is above. But let's just double check. Let's go ahead and set them equal. Let's see where they intersect at. We do need to set them equal. And about that.
So let's go ahead and add 3x squared, 2x squared, so 3x squared minus 15 equals 12. We're trying it, we can use the square root method. So add 15, works out pretty nicely. 3x squared equals 27. X squared equals 9. Square root, so x is plus or minus 3. It is plus or minus. So those are the x values they're going to intersect at. So to find the y values, go ahead and plug 3 and negative 3 into either one. It doesn't matter. So if I plug 3 in up here, 9 minus 15. negative 6, and if I plug in negative 3, since I'm squaring it, it's the same.
And those are just giving us points.
The points where they intersect that, so that helps kind of with your graph. Plus, you want it because it will give you the interval on your integral.
Oh, yeah.
So 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3 down here. So they're going to intersect down there. You can get a quick sketch if you want to. X squared minus 15, you're going to go down 15 and go up. It doesn't have to be perfect. That's a crappy parabola, but whatever. And then 12 minus 2x squared will be all the way up at 12, and you know it's going to look something like this. So again, it doesn't have to be perfect. Basically, we just want to know where they intersect at to get my interval, and we want to know which one's above and which one's below. So as I set up my integral, since we're in terms of x, it's going to be what minus what? Top minus bottom. What x values am I between?
Negative 3 and 3.
Negative 3 and 3. You keep everything in terms of x. All your functions are in terms of x. So your interval is also in terms of x. Your top function is
12x minus 2x squared. Or 12
12 minus 2x squared minus, parenthesis, x squared minus 15. Okay, if I subtract the negative, so negative x squared plus 15. Simplification a little bit, so negative 3x squared plus 27. I stared him down. Let's integrate this. So integrate negative 3x squared plus 27. X to the third negative plus 27x. So we're integrating it. Like I said, usually the ones with areas, whatever, two curves, you usually get decently nice polynomials. Okay, let's evaluate this. First fundamental theorem of calculus is plug in 3 minus plug in negative 3. So negative 27 plus 81. Is that what we decided? 27 times 3. Minus negative 3 cubed, positive 27 minus 81. So negative 27 plus 81, negative 54. Yes? Yeah. Positive 54. Plus 54. So 108. Yep. 'Kay.
Just because I didn't put a negative sign in front of my x.
Yes, well, I'll give you some credit, whatever they tell me to give you.
He'd give him no credit. He knew exactly what he was doing. He just forgot to do his algebra correctly one step. Take all of it.
Okay, so let's do a stopping point. We'll finish this tomorrow. We'll start a new one. Yeah, I'll go over questions on that. Don't forget homework quiz over review packet 2. I'll go over questions. Come see me if you need help.